Before we can go deeper into our study of quadratic relations and equations, let's investigate how we can recognize or identify linear and quadratic relations. We are going to compare each by looking at three different areas. And these three different areas are by graph, by equation, or by tables of values. Let's start with a comparison of the graphs for linear and quadratic relations. For linear relations, we know that the graph of a linear relation will be a straight line. On the other hand, a quadratic relation looks completely different. The graph of a polynomial quadratic relation forms a very specific shape that we call a parabola. The term parabola is used to describe this U-shaped kind of curve that you see on the screen. A parabola could also be flipped the other way around, and so you could have a parabola that looks like an upside down U-shaped curve. And this would also be representative of a quadratic relation. When it comes to comparing the equations for linear and quadratic relations, we can classify an equation as being linear or quadratic simply by looking at the degree of the polynomial. And you'll recall from a previous lesson that the degree of a polynomial is equal to the highest exponent that you see on a variable in an equation. We know that a linear relation will have a degree of 1, and a quadratic relation will have a degree of 2. If you have a degree that is neither 1 or 2, so maybe it's something higher than 2, we can classify this as being neither linear nor quadratic. So if we take a look at the first equation that we're given, which is the 2x plus y equals -1, we want to make sure that we have our equation in the right format. So this one actually needs a little bit of rearranging, and I'm going to actually bring the 2x over to the right-hand side. And by doing so, I'm putting it into y equals mx plus b format. And now if I take a look at the variable x and I look at the exponent that is attached to it, we've got an exponent of 1. And so with a degree of 1, we can say that this is a linear relation. In our second equation, the highest exponent that we see in the given equation is a value of 2. So that means that this is going to be a degree of 2, which makes it quadratic. In our third equation, it's not given to us in its fully simplified form, so we are going to have to FOIL both binomial brackets in order to get that simplified equation. And so if I collect like terms, I'd be left with x squared plus 3x plus 2. Now taking a look at this equation, the highest degree again that we see here is a 2, so this would also be quadratic. If we move on over to the second column and we take a look at our equation here, the highest degree that I see is a 3. So we've gone above a degree of 2, so that means this is actually going to be neither linear or quadratic. With our next equation, again, we don't have an equation that is given to us fully simplified. We've got 3x plus 2 squared. So sometimes students jump the gun and they see that exponent of 2 and they automatically classify it as being quadratic. However, you need to be looking at exponents on what we call variable terms. So 2 squared can actually be further simplified, and it can simplify to 4. So really this equation is y equals 3x plus 4. And then if we're looking at our highest degree, that would be the exponent of 1 that is attached to the x. So that means that this is going to be linear. And in our final equation, we are given -2 times x minus 1 squared plus 1. Remember that we can simplify this. We can take the portion that's inside the bracket and we can actually write it out 2 times. The squared symbolizes that it can be written out 2 times. So we're going to FOIL and collect like terms. And that's going to leave us with -2 times x squared minus 2x plus 1 plus 1. Now, this can be further simplified by distributing -2 inside the bracket. And so that would leave us with -2x squared plus 4x minus 2 plus 1. And again, I can collect like terms by putting together the -2 and the +1. So when we get our final equation, you can now take a look at finding the highest degree that is given. And so for us, that would be a value of 2. So that tells us that this equation is quadratic. A final criteria that we can take a look at is a table of values. And in order to compare something linear versus something quadratic, we have to take a look at calculating first differences and potentially calculating what we call second differences. Once you calculate first differences or second differences, there are specific patterns that you're going to see, which will help you conclude whether or not a relation is linear or quadratic. So let's take a look at this first table. The equation that's given to us is y equals 2x minus 3, and we are being told that this is representative of a linear relation. We know this because we can tell by the equation. The equation, first of all, is in y equals mx plus b format, so that obviously tells us right away that this is representing a linear relation. Again, you can also take a look at the degree of the equation, and so the highest degree that we see on our x variable is a 1, which says that it is linear. The first thing we want to do here is fill out the table of values. So we were given a chosen set of x values ranging from -2 to +2. And what we need to do is calculate their corresponding y values. So that means that we need to take each x value individually or separately, substitute it into its place in the given equation, and calculate the answer. So beginning with our first x value, this would read as 2 multiplied by -2, which is -4, minus 3, which would give us -7. And then we'd move on to the next one. 2 multiplied by -1, which is -2. -2 minus 3 would give us -5. And so we can continue this all the way down the rest of the table. And the rest of your values would be -3, -1, and +1. The next column in our table is meant to be used for first differences. Okay, and our rule of thumb is that we can block out or cross out the first box. And then we're going to actually start from the bottom. So we're going to look at our bottom or last value in the y column, which for us is a +1. And from that, we are going to subtract the value that is directly above it. And that happens to be a -1. So 1 minus -1 is +2. We're going to move up a row. And we're going to take a look at the y value here. The y value here is -1. And from this value, we are going to subtract the value directly above it, which would be -3. -1 minus -3 is +2. So we're going to continue the pattern upwards. And what you should discover is that all of your first differences work out to be +2. So when calculating first differences, if you find that you get the same value over and over, that means that you are working or dealing with a linear relation. So first differences are the same, that means that it is linear. If we move over to our second table, this time our equation is 2x squared plus x minus 3. We are told that it is quadratic, and again, you can check, because if you check the highest degree in the equation, that would be 2. And that codes for or represents a quadratic. Same idea, we are given a set of x values. We need to input them or substitute them into our given equation in order to calculate the corresponding y values. So be careful with this, because now you've got 2 places in the equation where you have to input your x values. So this would now read as 2 multiplied by -2 squared plus -2 minus 3. So pause the video, take a few seconds to fill in your y column, and then come back to the video to see the next step. So if we fill in the y column with our values, we get values of 3, -2, -3, 0, and 7. We can now proceed to calculate first differences. So we're going to block out the first box or the first row there, and we're going to go back to the bottom of the column. We're going to start with 7 and subtract the value on top of it, which happens to be 0. So we'll have 0 minus 7, which is equal to 7. 0 minus -3, -3 minus -2, and -2 minus 3. So when you calculate your answers, what you will notice right away is that you got a different number each time. So unlike the previous example where we got a very constant value of 2, this time we've generated a whole bunch of different numbers. So when your first differences are not constant or not the same, we can automatically conclude that this is not a linear relation. So now we want to check, well, if it's not linear, could it possibly be quadratic? So how do we do that? We need to go ahead and calculate second differences. And we're going to use the last column to do this. So I'm going to label my column second differences. And this time you are going to block out the first space, and you're actually also going to block out the second space. We're going to again go to the very bottom, but this time we're going to go to the bottom of the first difference column, and we're going to perform the same type of upwards subtraction. So I'm going to start with my bottom value of 7, and from 7 I'm going to subtract the value directly above it, which is 3. And then I would have 3 minus -1, and -1 minus -5. If we calculate our first differences, what we find is that we get a value of 4 each time. So this time we have second differences that are constant or the same. So when you have second differences that are the same, we can conclude then that our relation is quadratic. So just to recap, if you calculate your first differences and you find that they are constant, meaning they are the same value or you get the same value over and over, we can conclude then that the relation is linear. If you calculate your first differences and they are not constant or they are not the same, then you would proceed to calculate second differences. If your second differences are constant or the same, then we can conclude that the relation is quadratic. Now, what if you calculated second differences and again, you got totally different random numbers? Well, then that proves that the equation or the relation is not linear. It's not quadratic. You could conclude then that it is neither linear or quadratic. So to quickly summarize what we talked about in this lesson, we looked at comparing linear and quadratic relations, and we compared them for 3 different categories: the graph, the equation, and the table of values. When dealing with a linear relation, the graph will always be linear, meaning you will be able to see or graph or plot data that will form a straight line. If we're taking a look at an equation, you will find that the highest degree on a variable in an equation will be a degree of 1. And if we're using a table of values, we would find that if we were to calculate the first differences, we would have first differences that are constant. For a quadratic relation, the graph would take on a very specific shape that we call a parabola. So that is a U-shaped looking curve that can open either upwards or downwards. If we're taking a look at an equation for a quadratic relation, the highest degree that you would find would be a degree of 2. If we were looking at a table of values, you would start by calculating first differences, but your first differences would not be constant. That would signify that you now need to calculate second differences. And when you calculate the second differences, if you are having or dealing with a quadratic relation, you will find that the second differences are constant.